If you're building a RAG application, you should be using hybrid search and re-rankers. In today's episode of Systematically Improving RAG Applications, we're going to talk about the importance of continuously improving RAG applications and the surprising effectiveness of BM25 as a baseline for many, many search tasks.
What's surprising is that in a lot of tasks and data sets, BM25 actually is a better or higher baseline than vector search. Going from demo to production doesn't mean you make one big leap to perfection. It's about continuously improving your application. With LanceDB, you can find it in our documentation and how to actually use the hybrid search in practice. So what you're essentially doing is, hey everyone, we're going to talk about a particular topic on improving your RAG systems called hybrid search. And this is sort of split into sort of three different components: multiple recallers, hybrid search techniques, and then re-ranking. We'll dive into it, and then we'll see some practical results that we've seen ourselves. All right, so if you have problems seeing the slides, let me know. I'm going to assume the screen share is working. So, hey everyone, my name is Chang She. I'm the CEO and co-founder of LanceDB. Thank you for being LanceDB users, and would love to hear your feedback, either on the open source or if you've signed up for the private preview for LanceDB Cloud, if we can make it better for you somehow, or if there are pain points that you wish you didn't have to fight, please let me know. On Twitter, this is my handle. Follow me. I'm mostly tweeting about vector search, AI, machine learning, and working with data. So these days I spend about equal time tweeting and coding, although I think this was a few months ago, so I probably spend more time tweeting now than working on GitHub. So I've been working in the data tool space for about 2 decades, making tools for data scientists and machine learning engineers. I was one of the original co-authors of Pandas. I spent a bunch of time in big data and then recommender systems. And my last job at TubiTV, a streaming company, was what gave me the original idea to start LanceDB, to make it easier to work with multimodal data for machine learning and AI. And I'm using this as an umbrella term to include everything from embeddings and text to images, videos, and beyond. This year, we talked to a lot of folks putting RAG and semantic search AI native applications into production. And I think even though we've made a lot of progress since last year, I think there's still a pretty significant demo to production gap in RAG. And I think this is why I'm really excited to be here, because I think the goal of this course is to basically address this gap in a very pragmatic and practical way. What are people fighting with? Quality of the retrieval, right? It's pretty easy to just throw up like simple vector search and throw up a demo. You get maybe like 50, 60% accuracy. How do you get to that 90% accuracy or beyond, where that's good enough for production? And then one thing we're seeing is going from demo to production doesn't mean you make one big leap to perfection. It's about continuously improving your applications, which also means things that you guys have probably covered or will cover around like evals and different components of the system that you can tune. And so the way I think about this as a self-improvement loop is a composable system for the different parts of a RAG application, from chunking to the retrieval to the storage to the embedding space itself. All of these things should have well-working components that work well with each other. And then you have user feedback in a feedback loop where you can use that to fine-tune all of your processes. And that feedback loop, obviously coupled with evals and fine-tuning processes, is what gets you this self-improvement loop, right? So for this short talk, we're only going to focus on a small part of that system, which is around hybrid search and re-ranking to improve the quality of retrieval, right? One of the things when I talk to folks who are asking me for advice on how to build RAG applications, especially vector search, is I tell them maybe don't start with vector search and actually start with full text search or BM25, right? And maybe as a CEO of a vector database company, maybe I shouldn't be saying that, but in terms of making high quality AI applications with the least amount of effort, this is a great baseline to start. BM25 has been around for a long time and it's really high quality. And if you see as much results as we do, what's surprising is that in a lot of tasks and data sets, BM25 actually is a better or higher baseline than vector search. So for example, in the screenshot, you'll see that FTS here on the bottom, and actually outperforms vector search here on the hit rate metric. Right? And so you'll never really know for sure which is going to be better in the outset, but BM25 is so easy to get started that I always recommend that as a first baseline. I'm not going to bother explaining how vector search works. I'm kind of assuming you guys already went over that in the course. Happy to provide more detail if folks are still interested, but I will kind of go through a little bit on what BM25 and full text search does just as a refresher. And I want to use this as a way to help you guys build intuition on why BM25 works well and how it can be complementary to vector search. So BM25 BM stands for best match. And if I remember correctly, BM means it was the 25th iteration of this particular algorithm. And BM25 was released, I think, in 1994, 1995. So it's been around for a long time. Despite recent claims, it has not been beaten and for full text search. And it is still the king for text-based search. The scoring formula for a particular query in a particular document is split into two this is a simplified picture, but split into two terms. One is the IDF term, which is the inverted document frequency, and the other one is the term frequency. The second term in this score formula is about the frequency of occurrences of your query. And the first IDF term is about how it ends up being about how rare your term is across all of the documents. Right. And so here rarity matters. And I'm not going to go deep into the formula, but the thing that's worth highlighting here is that if you have terms that are rare across your corpus, that actually boosts the score. And so if you're searching for like an exact match or a syntactic match across your corpus, this is probably kind of the intuition that you can think about as to why sometimes BM25 will actually work better. And it's not strictly, one will not strictly dominate the other across all queries and all documents. And this is great because then this gives us an opportunity to actually put these two together. Yeah, the number of iterations definitely will increase. I think most recent attempt was an algorithm called BM42, which I'm not sure if they've iterated on it that many times, but it was more of a Hitchhiker's Guide to the Galaxy reference.
Hey, are your RAG applications falling short despite using the latest frameworks and models? You're not alone. I'm Jason Liu, and I've helped a dozen companies improve their AI applications. I've developed a systematic approach that delivers results. If you want to check it out, join my free 6-week email course and learn the techniques I use in my own consulting practice. That way, you can stop guessing at what works and measure what matters. Just check out improvingrag.com.
So one thing with, I talk a lot about BM25, full text search, it works really well. Well, do we even need vector search? So one is the BM25 does not capture semantic meaning. So the sort of a grossly simplified way to think about it is, if you search for the term person, you'll get person, persons, any document that has the word person from full text search. But what you won't get is words that are semantically similar, like customer or maybe user or maybe early adopter, right? And these are the things that we can rely on vector search to return semantic meaning. Vector search also tends to have more predictable latency. So embedding vectors are dense vectors, and more or less the latency of every query for the same parameters is going to be the same. Whereas for BM25, because it's sparse and depending on the number of terms that are in the sparse vectors, that latency can actually vary a little bit more. And of course, as I mentioned, vector search and BM25 are complementary. They're not necessarily mutually exclusive. And that sort of brings us to the next question, which is, okay, if we do both BM25 and vector search, right, we're going to get multiple result sets. And if we only want the top 10 or the top 3 to feed into generation, how do we actually combine those results? And how do we think about the ordering of those things? And this is where hybrid search comes in. The way I think about hybrid search is kind of there's two ways to combine these results. One is rank fusion or reciprocal rank fusion, and the other one is model-based approach around using re-ranking models. I'm not sure if this is already covered in the course. If this is, please just interrupt me if this is already old hat. But essentially, this is the formula for reciprocal rank fusion. And essentially, it weights. So this is the sum of the ranks across all of your recallers. So here, we're going to be talking about 2. But if you look at the literature out there, there's actually even more retrieval techniques with, graph databases, other filtering techniques, and things that are much more niche to particular use cases. And so if you have multiple recall results, whether that's multiple retrieval techniques or embedding models, doesn't matter. You take the local rank of each result and you add them up. And then you take this inverted term here. K is sort of a magic constant that in practice, I think the most common setting is 60, but it can differ depending on your application. All right. And then the R here is the particular recaller. The way to think about this is, one, we don't want to use the raw distance scores or the similarity scores that comes out of each recaller, because those scores aren't comparable to each other. And so you can't really be aggregating them together, comparing them with each other. Instead, we'll use the ranks. And then 2, the way to aggregate these ranks by using this formula is so that when multiple recallers rank the same result higher, then the total rank will also be higher for that particular document. Right? For this kind of a re-ranking method, it is pretty fast. There's no additional model. The formula is very easy to compute. The winning aspects here for reciprocal rank fusion is just really simple and it's really fast to do. Right? So if you want better or more accurate results, you may want to end up using a model. Model-based re-rankers will typically use the retrieved text rather than the scores from each recaller. So these re-ranker models, it's actually a pretty trodden technique from recommender system land. And these models tend to be a little bit more expensive. So what you're doing is you're running the ranking process on this expensive model on a much smaller set of documents. Typically, like if you're getting the top 10 from 2 or 3 recallers, right? You're ranking 30 documents out of maybe 10 million or 50 million or something like that. And what we see people do is there's 2 flavors. One, you can use open source models from Hugging Face, Cross Encoder, Colbert as BGE, dedicated BGE re-ranker models. You can prompt ChatGPT or GPT into becoming a re-ranker as well, which is kind of interesting. And then there are dedicated third-party APIs. So Cohere is probably the original one that had a re-ranker API, and that works very well. Gina AI also released a new one, and then it was quickly followed by Cohere's new re-ranker model. We've done some experiments, so this is sort of an unpublished blog post we're almost ready to hit release on. But essentially what we did was look at 2 data sets, Squad, which is the Stanford Q&A dataset, and the Llama 2 review dataset, essentially looking at vector search, full text search, and then hybrid search, and each option with different re-rankers. So if you look at, for the Squad one, if you look at just pure vector search, we're getting somewhere around like 80, 81.3 for hit rate. And then the best here option is at the bottom here with hybrid search using both of them, and then re-ranked using Cohere. And that one is you get a good 10 points, 11 points in hit rate improvement, which is pretty substantial. We'll be publishing these results pretty soon, and you'll be able to take a look at the full results here. Part of this is we have Ayush created a weights and biases project with all of the different results. I think I'm not sure if this is shared here, but it's probably something that you can kind of follow along. And then all of the code you can find in LanceDB/ragged repository with different evaluators, and you can run it. Real quick is how do you actually use hybrid search and re-ranking? So this is a pretty easy code snippet. So one is you specify hybrid as the query type here, and then you add a re-ranker API call, and you can use Colbert or other things.
Thanks for watching. If you liked that video, make sure to like and subscribe. And if you want to learn more, check out improvingrag.com. We're going to talk about the foundations and not frameworks. Over 6 emails, you're going to learn how to overcome absence blindness, as well as how to fine-tune language models, understanding diverse query types, improving multimodal RAG, and ultimately smart question routing, and build a UX that collects user feedback. Just check out improvingrag.com and fill out this quick email address at the bottom.